So this video is about paths and collisions that are modeled using quadratic equations. Let's take a look at the problem and read it. There's quite a bit of information here. It says two boats leave a dock. The first, a sailboat, travels a path described by the equation y equals x squared minus 2x plus 16. The second, a fishing boat, travels a path described by the equation y equals 2.5x squared minus 9.5x plus 16. There is a bridge located at 0, 0. The x-axis represents the distance east from the bridge in nautical miles, and the y-axis represents the distance north from the bridge in nautical miles. Graph the path of each boat using the table in your calculator. Label the axes, dock, bridge, and the point of collision. How far east did the collision occur, and how far north did the collision occur? So at this point in the problem, I'm kind of on information overload, to be honest with you. So I'm going to start with what I know, and that is that they told me that there was a bridge located at 0, 0. So I can put a dot on this graph and make a little arrow and call that the bridge. So I want to try to figure out what's going on here. The other information that they've given me is that the x-axis represents how far east I am from the bridge in nautical miles. So I always label my axes. So I've done that. And I'm getting kind of an idea of what this means. For example, if there was a boat sitting right here at 20, 0, that boat would be 20 nautical miles east of the bridge. So I also know that this represents north in nautical miles. And I'm going to abbreviate there. And so I've got some kind of path of these boats, and at some point they collide. So I'm going to go ahead and graph the path of each boat, like the instructions say. And it says just to use the table in your calculator. So what I did was I put in both equations. And this is just going to graph the first equation. Let me show you my y equals. I'm graphing this equation right here. I've got this one in, but it's not being graphed. I've unhighlighted the equal to, so it's not being graphed right now. So when I hit graph, I'm seeing the path of the first boat. And I can graph that by going to my table, and I can graph these ordered pairs. 0, 16, 1, 15, 2, 16, and so forth. So let's put some of those numbers onto our graph. 0, 16 would be right there. 1, 15 would be there. 2, 16. 3, 19. 4 at 24. 1, 2, 3, 4. And 24. 5 is at 31. 1, 2, 3, 4, 5. And 31. And we're just about off of our graph. So what that tells me is this sailboat has traveled a path that looks something like that. So now it says graph the path of each boat. So let's put them both on the coordinate plane. I'm going to go back to my y equal, and I'm going to move the cursor over to the equal sign and hit enter. And you'll notice it's now highlighted. So I'm going to be graphing that. I'm going to move my cursor to the equal sign and hit enter, and you'll notice now it's unhighlighted. So when I hit graph, I get the one I had in Y1. And I'm interested in graphing the path of this boat. This is the second boat, the fishing boat. And I'm going to use the same technique. I'm going to go to my table, and I'm going to graph based on these ordered pairs. So 0, 16, 1 comma 9, and so forth. So 0, 16 is right there. 1 comma 9 would be there. 2, 7, about right there. 3, 10, 1, 2, 3, and then up to 10. 4, 18, 1, 2, 3, 4, and 18 looks like it's there. And 5, 31, 1, 2, 3, 4, 5. And you'll notice we already have that point graphed on the other parabola. So it looks like this is my fishing boat, and this is my sailboat. And it looks like what they do is they swing away from the dock and travel kind of in the direction of the bridge for a little bit. And then they both turn around and they head away from the bridge. And the point where they collide is right here, and I know that is 5, 31. So let me go back to the instructions and see if I've got everything labeled the way I need to. It says, label the axes. I did that. Label the dock. Oh, I haven't done that yet. So taking a look at this, it looks like this point right here, my y-intercept, has to be the dock from which both boats departed. So again, I'm checking to make sure I've done everything. I've labeled my axes, I've labeled my dock. I do have the bridge labeled, and let's write collision here. So there's no ambiguity about that. So it says how far east did the collision occur, and that's going to have to be my x value right here, 5 nautical miles, and I'm abbreviating for speed here. And how far north, 31 nautical miles. That's my y value because my y-axis represents how far north I am from the bridge. That's my x value because x represents how far east I am from the bridge. Now, there's a way to check this. Using your calculator, you can graph both of the equations at one time. So I'm going to move my cursor to the equal sign and highlight them both. And you'll notice when I hit graph, now I get both of my quadratic equations. And we've done second and calc to go to the calc menu. And what we want to do is we want to find the intersection of these two equations, option 5. And so my calculator asks me, which two curves are you interested in looking at? And see, my cursor is moving on this parabola down at the bottom, and I'm going to say, yes, that's one of my curves. And yes, this is the other. And then it asks me to guess, and I'm just going to move it as close as I can to the intersection I'm looking for and hit enter. And my calculator will give me the answer 5, 31, which simply reinforces what I found when I graphed it by hand. I can also take a look at the table of values and notice that right here when x is 5, both of my y values is 31. So that means that's a point that both of these parabolas share. So that is how to do a problem involving paths of things and collisions of things.